Good morning. So we are the High Performance Research Computing Center, and today we're going to talk about one of our primers, Introduction to Linux. Before we jump into the primer, I want to talk a little bit about myself. So I am Aditi Saluja. I am a graduate assistant research here at HPRC. HPRC falls under the Division of Research, and we have supercomputing resources that helps in accelerating research for Texas A&M University and external researchers as well. Throughout the course of the year, we offer a lot of primers and short courses. And this spring, this is the first primer that we are teaching, Introduction to Linux. So this demonstration is going to be through the open on-demand portal that we have created. That's like a in-browser session through which you can access our servers. And we're going to talk a little bit more about it as we dive in. So I would like to welcome all of you. And I also want to educate everyone that we have two audiences here. We have Texas A&M people who are joining this call, and also people from Access, which is a NSF-funded research program. So we have external users also joining us. So as I walk you through the program, there'll be some instructions which might be different for the Texas A&M people and the Access users. So I'm going to differentiate it, and we have an amazing team of help desk student workers who will be assisting you in the chat for any questions or doubts that you have, or any logistical problem that you are facing while trying to log into our service. So let's get started. So first, I want to talk about our resource FASTER. FASTER is a 184 node Intel cluster. So this is the cluster that we're going to be using today for our course. FASTER is a 184 node Intel cluster from Dell with the HDR100 InfiniBand. So InfiniBand is basically a communication standard that is used in communications, in computer networking, and it is used as a data interconnect across different computers on a server. There are tons of GPUs on FASTER cluster, A100, A10, A30, A40, and T4, which are all GPUs by NVIDIA, and they're distributed, and they're distributed and composed via liquid PCI fabrics. So what is different about this supercomputer cluster is that it is a composable architecture, which is different from our traditional supercomputer clusters, wherein you have a fixed number of CPUs or GPUs on a particular node. But here, FASTER is a composable supercomputer cluster that allows you to request any number of CPUs and GPUs combination based on the workload that you want to run. I'm not going to dive deeper into this because today itself in the afternoon, we have another primer that's Introduction to FASTER, and we're going to dive deeper into the hardware and all the node specifications and other specifications about FASTER, how you can use FASTER, and how you can benefit from FASTER. So I request if anybody is interested in learning about our this resource, then please join the primer in the afternoon as well. Other than FASTER, we have two other resources, Grace and Terra as well. So if you are interested, you can also request for an account on those clusters. So moving on. So this is an announcement that I have to make, that you should not share your password for the HPRC account that you have applied. Do not share your account with any of the users. Every user should have a single account because it is prohibited by Texas law as well as Texas A&M University to share passwords or accounts. Now, how we can access the HPRC portal? Let's get into it. So this is the HPRC webpage. I hope everybody has access to the slide decks so that they can follow along as we go through this course. I request somebody from the channel to ping the link in the chat as well about the slides. If someone doesn't have the slides that we are following, it will be helpful. So this is the HPRC web page, and here we have for TAMU users, this is the link that we have. You can use this to access the portal. And then for the ACES users, we have this link. So I'm gonna tell you how you can navigate to our Linux cluster through this open on-demand portal that we are on. So this is how the portal looks as you log in through the faster portal for TAMU users, and you will be redirected to this page if you are an ACES user. Yeah, so Zenua has also pinged the links in the chat, so please feel free to use these links. Now let's try to log into the cluster. This is the faster shell access. So I am redirected to this terminal and I'll be prompted to ask my password. So I have to. After entering the password, we have two-factor authentication enabled. So you will get a duo push as well once you log in through this. And only after the duo is authenticated, you'll be able to log into a cluster. So I am currently doing the two-factor authentication on my mobile phone and trying to log into the cluster. I think there's a network timeout error. I'll have to probably log in again. So let's try that. And I request everyone to follow along and try to log into our cluster as I am proceeding through this course, because that will help you to understand the resources better and also follow along the course. So I am able to log into the faster system. This is for the TAMU users. If you are a ACES access user, then you can use this this page over here to access our clusters using the access ID and password that you have, and you will be redirected to this page. So if anybody is having any login issues, please let us know and we'll try to assist you throughout the course of this primer. Okay, so moving on, I am assuming that everybody is able to access our portal, and you can even go to our website, hprc.tamu.edu, and there's a portal option in the menu over here, which gives you the links for the faster portal for TAMU users and faster portal for access users. I hope that's pretty clear. So let's move on. So for the access users, when you are redirected to this page, after the logon, I was already logged in, so I was directly redirected to the page, but you will be prompted to enter your username and your password, and then you'll be able to log into the dashboard that we have for our resource. And I've already walked you through this. So this faster shell access basically starts an in-browser Linux terminal on faster. We have created this on-demand portal because it allows a convenient shell access anywhere within a web browser. This is specifically for the Texas A&M users. So you can also log into our cluster using SSH. So SSH is a secure shell command. It's a network protocol that allows you to securely access a remote server. And this basically is a command. This is SSH -x your net ID @faster.hprc.tamu.edu. So if anybody has a Linux terminal and they want to use this protocol to log into a cluster, they can also use that if you don't prefer the OOD portal. Okay, so let's try this command SSH -x faster.hprc.tamu.edu. Again, this is going to ask you to enter your password and the duo factor authentication. And voila, I'm logged into the cluster. So that's another way to log into our system, but this is only useful for the Texas A&M users, as the external users will not directly be able to SSH to our system. And you would have noticed that I used the -x command with the SSH, the -x flag. So that's used for enabling the X11 forwarding. So basically, if you want to open any graphical user interface application on your remote server and then pass on its display to your local machine, that's how you do that. So for viewing images or using a GUI software, that's how we enable the X11 forwarding for your local system. So that's the -x flag for that. So finally, after we have logged into your system, let's get to the meat of the thing. So we are here to learn about Linux. Linux is an open source operating system. And we are going to be talking about some of the commands that we can use to interact with this operating system and to be able to perform some basic functions on it. The first command that I want to talk about is the print working directory. So there is a directory structure on Linux, and the pwd command, it tells us exactly where we are in that directory structure. If you're typing out these commands with us, just for the sake of clarity, in the slide deck, the commands are going to be in green. And if you want to verify that your output is correct, you can see that the output is going to be in blue. So since I want everyone to be following, so we are going to use the OOD portal to try all these commands. And so I think we were logged into this portal here. So this is faster. So let's write print working directory and see where we are. So I am in the home directory. So this is the address of where I am in the Linux directory. So you have learned about a new command, print working directory. The next command that we're going to talk about is ls. ls is the list contents of your working directory. So if you type ls here, it's going to show all the files that are here in my system. So I am going to go to, yeah. So I want to show a little bit more files in this directory over here. There are tons of files, and some are in blue color, some are in red color, some are in green. So there are variable colors also of these files, and these colors do have a meaning, and we're going to talk about it. But right now we learned how to understand where we are in the Linux directory structure with the pwd command, and then what all contents are there in the directory that I am currently in, so that we can find out with the ls command. Moving on. So I talked about the Linux directory structure. So finding your way around Linux directory structure is very important. File system hierarchy is used to determine the Linux directory structure. So it's basically a tree. And in the tree, on the very top, you have root. So everything that is inside the Linux will be inside this root folder. And then you have certain folders such as the temp directory, the etc directory, the home directory, the variable directory, the bin directory. So there are a lot of directories. These directories, the temp mostly contains temporary files, and variable also has certain variable files. And when you install a new software, there are certain binary files also that are associated with it, which go into a certain folder called as bin. So these are system level configuration folders that holds the configurations of different software on Linux. When we log into the cluster, we are redirected to the home directory. So on the cluster, there are hundreds of people who are using it, and all of them have a dedicated space in the home directory and a dedicated home folder. So when we saw print working directory, the address was home Aditi's home /home/saluja.aditi5. So that is where I have logged into the cluster. Okay, so moving on. Let's now talk about a few more Linux commands that will help you to understand how to see the files that are in the directory and how to navigate your way around these directories. So we talked about the ls command. Now there's something called as the flags also, and there are parameters and options that you can pass to these commands. The double dash here, it means or that it is a single option, and this is a descriptive word, ls hyphen hyphen all. So this shows that it shows all the files, including the hidden files which begin with a dot. So if I do ls all here, it's going to show me all the files, including the hidden files. The hidden files, they start with a .conda, .vs code server. So hidden files are also available. But when I did a ls, if you can see, these files I could not see in the directory over here. If you use a single dash, then each character is an option. Minus a signifies something and minus l signifies something. The minus a option here, it shows all the files, including the hidden files, and the minus l, it shows the file details. So we have ls minus a minus l. If we do that, then minus L stands for the long list format. You're going to see all the files and all the details regarding the files, who is the owner, what are the permissions on the file size, when they were created. All that information is going to be there. Another important thing is that we can combine these options together with a single dash. So the same thing that I did, ls minus a minus minus l, it's actually same as ls minus al. So if we do ls minus al, even then the output is going to be the same. We will have the same output if we use ls minus al as we had when we space them out. So we can combine certain options with a single dash. Very important thing that I want to mention with respect to Linux, the dot represents the current working directory that we are in, and double dot represents the parent directory, the directory that comes before the working directory that we are in. So we're going to be using the dot and double dot notations throughout the course. So I wanted to familiarize you with that. Dot stands for current working directory, and double dot, it stands for the parent directory. Okay, now you said you must be thinking that I'm throwing commands at you, list items and parameters. How can one understand all these commands? I completely get you. It's very difficult to remember all the commands. And I remember when I started working as a software developer, I used to think that I suck at Linux because I do not understand any commands. But with time you realize that it's more about understanding of the system and not about cramming the commands, and we have certain tools that can help us understand the commands. So one way is to Google search the commands that you want to use. Another way is the Linux way, is to use the man page, the manual page. So you can find more about a particular command using this command man, which stands for manual. And if you want to learn about ls using the man command, I'm going to do man ls. And this will show me everything about ls command, what it stands for, list directory contents, and the options that you can include with it, its description, and all the various parameters that we can pass to it. So all the flags, all the options that can be combined with the ls command are here, and we can find it using a simple man command. Interesting thing is we can also man the man command. So if we do man, we can also find out what man stands for. Man's an interface to the online reference manuals. So you can learn about any command using the man command in Linux. Moving on, some common directory commands. There are three commands here that we want to talk about: how to create a new directory, how to move around the directories to change the directory, and third is how to remove an empty directory. So often we want to get rid of the old files, so we remove the empty directories. um, let's try creating a directory. So let's create Linux primer. So I have now created a new directory called Linux_primer. Here, this mkdir it's basically a command that Linux recognizes. If you do this Linux primer, it's going to throw you an error because Linux doesn't recognize this command. So this is the first command for directories: make directory mkdir. Now, I want to navigate to the new directory that I've just created. Let's try to do that. We do that with the cd command, which stands for change directory. Okay, I thought we had something in the chat. Okay, continuing. CD stands for change directory. So let's go to the directory that we just created. Now I am here inside the Linux primer directory, and we can verify that by using the pwd command. So you can see the path right now is scratch user saluja.aditi5 /linux_primer. That's exactly where I am currently. And if I do a ls inside it, I'm not going to get anything because we have not created any file so far. So it's an empty directory. Now, if we want to remove this empty directory, what we can do is we will use the rmdir remove directory command. But before that, if I use the remove directory command here, will it work? It will not work because I am currently inside the directory. So it is not able to recognize Linux primer inside it. There is no directory such as Linux primer within this directory. What we need to do is we need to navigate our way back. So we will do change directory. And we talked about this, that double dot stands for the parent directory. So we go to cd ... And now if we do print working directory, we are outside the Linux primer directory. Let's now try to use the remove directory Linux primer command. And now the directory has been removed. So these are the three commands summarizing the common directory commands: make directory, change directory, and remove directory. Okay, moving on. So the files and the directories in Linux, they have permissions, and they also have certain colors associated with it, which represent certain attributes about the file. So if you see a file with a turquoise color, a teal color, that represents a symbolic link. I know that everybody would have used Windows at some point of time. So in Windows, if there are some important files and we want to create a shortcut on the desktop, so the shortcut is on the desktop, but it actually might be somewhere else in the documents or some other folder. So symbolic link is exactly like that in Linux. We are trying to create a pointer to some other file that's located somewhere else. The second one is green. So green, it represents the executable files. Generally, all the scripts that we execute, the Python scripts, the shell scripts, they are executable files. Then we have red, which is the compressed files, the tarballs, the tar files, all the files that are grouped together. So they are in red color. You can see here data.gz. So that's a compressed file. These ones are executable files. And then purple, that stands for image files. Often in machine learning, we deal with the image recognition models such as ResNet 50 and many other models. And if we want to train on these data, we make use of tons of images. And you can clearly identify these images with the color of the purple color. So that's image.jpg. All the directories in Linux, they are represented by the blue color that we have here. And finally, the text files, they are white in color. So the README files or the .txt files are going to be white in color. So let's do a simple ls here and see these colors. So if you see all the blue files over here, so they are all directories. This wrapper.sh is an executable file. These license Docker file, these are right now, these are all they are just white plain files. They're not executable. And you see a zip file over here, that's a compressed file, and that's why it's in red color. I hope that these attributes are clear. If anybody has any questions, please feel free to ask them by unmuting yourself or put your questions in the chat and we can try to help you. Let's do a simple exercise and see what we have learned until now and practice the cd command and the other make directory commands that we have. Let's start with this. Let's make the temp directory and follow this path over here. So we have make directory temp. Then there is another directory that we create inside this, make directory temp hg19, okay? And then let's move one step to temp. After that, we do print working directory. You can see that's the path that we come up with, scratch user saluja.aditi5, and that's the temp folder that we are in. So scratch is a directory that is there on our systems. And if you want to learn more about how to where should you run your workloads, we have scratch and home directories. We'll be covering that in the afternoon session today in the introduction to faster clusters, so please join that as well. Okay, yeah, so we are inside the temp directory and we created another one, hg19. Let's try to change directory to hg19 and do a pwd over here. So we have now the path over here is saluja.aditi5 temp hg19. Yes, so let's use cd. If we do cd, where is it gonna take us? Can anyone tell us? Where will we be with this change directory command? Anyone? I hope everyone understands this. Okay, so the double dot, I'll tell you. So the double dot, it stands for we talked about the parent directory. And when I add a slash and I add the double dot multiple times, so it's going to take me 2 steps back. So imagine you're doing something on Word and you you added 2 words and then you press the undo button twice. So that is going to take you back 2 steps back. It'll take you 2 steps back. So this is what it's going to do with respect to directories. This command, if I do a print working directory, it's going to take me outside the temp directory. So we jumped into directories temp and hg19, and now with this command we jumped out of the temp directory. So we took 2 jumps back. So that is what this change directory stands for, and the double dot, that's how it comes into use. Another important parameter, like option with the cd command is this cd dash. So what happens if I use cd dash? If I do this, I will be taken back to the last step that I was at. So if so I was in the hg19 directory, so I'm redirected back to that directory. And it's actually a very powerful command if you see, because oftentimes directories are like multiple levels deep. So there is not just one directory inside another. There are tens of levels of directories inside it, and then you have to edit one text file inside it, and then you go back to some another path and change some other file, and then you forget the path of the older directory. So if you just do cd hyphen, it will take you back to the last step that you were at. So it's actually a very powerful command when we are dealing with a directory that has multiple directories within it and multiple files within it. So if we do a pwd here, again, we are inside the hg19 directory. And yeah, so I think that's it. That's the command that I wanted to talk about on this page, the cd hyphen command. Moving on, so we have the absolute and relative path for each directory. So absolute path is with reference to the root directory, with reference to the Linux where a particular directory is. So the address that we see for this directory, home Chris project, so that is its absolute path. But we also have relative paths. So relative paths is with respect to a given directory, where is the current, where is my current file or my current directory. So the readme file, if I want to find the relative path to readme, so that is going to be go 2 steps back. That's what this means, double dot. In the previous directory, go to the docs folder, and there you will find the readme file. So this address is a relative address because it is relative to the directory. And if we do this ls /home /chris /docs readme, that is its absolute. This is the absolute path for the readme file. So just if we just talk about it, it's like absolute address for a home would be like 3645 Welborn Road, Reveille Ranch, Bryan, Texas. So that's its absolute path. But it also has a relative path with respect to the homes that are all around it. So that's what we mean by absolute and relative path in Linux. Okay. The next section is going to be about the history of your commands. All the commands that we type in our Linux shell, they are saved to a file in the home directory known as .bash_history. So if I press an upward key, if you press the upward key on your keyboard, you'll be able to see all the past commands that we have been talking about right now. All the history is saved. So how am I able to access this? I'm able to access these things because there is a history, there is a file .bash history, which tracks all the commands that we have been using so far. Okay, so let's try to type history and see all the commands that are there. If I say history, it's gonna show all the, it's showing up to like 1026 commands, all the commands that are here that I've used so far. So all of them are in the directory. So let's say I am running, where this comes useful is when I am doing an important experiment. And in research, there is a lot of experimentation, and sometimes it's a hit and a miss. Some experiments succeed, some don't. We should document both, but how sometimes we forget, as we are coding, we forget to document these things. And it's important to remember the exact commands that we have been using to document stuff. So we can use the history command to access the commands that we had used before, and we can use that in our documentation. If I really want to just get the last 20 commands or last 10 commands, then I can use history and combine it with this pipe operator and use another command called as tail. So tail, what this is doing is that the output of history will be redirected to go to the tail command, and tail command is going to give me the output. By default, it is set to last 10 commands. So this should give me the last 10 commands in the history, and it is also giving me the current output that we entered right now. So that's the beauty of it. Captures everything, all the commands, so that you can it's easier basically, and you don't have to type commands again and again, and you can use upward and downward keys on your system to basically navigate through the commands. And you don't, initially in the beginning, it's very useful because you don't even remember the commands. Okay, the next thing that we want to talk about is the redirection operators. The redirection operators, the less sign over here, it redirects the input. So if we have a program and we want to take input from a file, then there can be a specific input file that this program will be taking the input from this input file. Oftentimes, what happens is that there are the input is very huge, and you can't type it out on the command line. So it has to be organized in an input file. And this operator, it helps us take that input while we are trying to run a particular program. So let's say we have a Python script, and the Python script has 20 parameters in it that we want to pass it. And instead of writing those 20 parameters on the Linux shell, you can actually put them, organize them in an input file, and the redirection operator will take that input from the input file. The second one is the output. The greater than sign, the less than is for redirecting the input, and the less than is redirects output. So we have command greater than out.txt. The output of this command will be captured in the out.txt file. This command, the third one over here, greater than, this appends the output to a file. So if we have the output of this command will be appended to out.txt. And then we have the less than sign, the fourth one. This is input from HPRC. So if we want to take multi-line input on the terminal itself, you can define a delimiter, and these dot represents all the lines of code that we want to type, and then you end the delimiter so that you'll be able to capture all the multi-line input on the bash terminal through this. But this is the recommended way, like taking the input from a file. So let's there's a difference in important difference. This one, the greater than one, it's going to completely override the file, the out.txt, and the greater than the double greater than one, the third one over here, is going to append the output. So let's try to experience this in the shell itself. So let's say I want to capture the command of this history since we are building on it. Let's just do that history, and let's write a out.txt file. So now the output of the history command will be here in the out.txt file. We can open this. So I'm using, don't be afraid if you've not seen it before, but this is Vim is an editor in Linux. So it's inbuilt in Linux. So we can use it, vim out.txt. If I open this file, so yeah. Okay, so what I did here was I used the same command history pipe tail, so that gives me the last 10 commands, and I redirected it to the out.txt file. Now an opportunity for you to learn another very useful command, cat. The cat command is used to show the contents of the file. So I did cat out.txt, and the output of this file I can see over here. So this output is not coming from this history.tail command, but this is actually within the out.txt file. So it has been written in the redirected to that file. But now let's say we want to append some output to it. So let's do the history tail, and let's again use this. Now we are using this different redirection operator. This one, this is going to append the output to the out.txt. So ideally, there should be 20 lines in the out.txt. Let's find out. Yeah, so now you can see the output has been appended. So like if you see here, 32 and 21, there are like 20, there should be 20 lines over here. First, we had 10 lines that we got from this command. We appended the output of the 10 commands that we got, last 10 commands in the history output, and we put it in the out.txt file. And then we appended the output again of the last, again, we used the same history command and took again the last 10 commands. And instead of overwriting it, we just appended it. If I'm again going to do the same thing that we did before, and now I'm going to cat out.txt, again, this has just 10 files because again, using this command, we have overwritten the contents of out.txt. This appends the output and this overwrites the output. There are some other redirection operators over here that you can understand and go into a little more detail if you want, but we're not going to dive into it right now. A very important attribute, chmod, or some people call it chmod. So important thing over here to understand is that every file has 3 permissions: read, write, and execute. So often we have to change these permissions and give certain users access to certain files. They should be able to read, write, and execute the files. Also, there are 3 types of owners of a file. One is the user itself who has created the file. Then there can be Linux groups also. So some certain people might be working together. So they are within one Linux group. And third one, so they're all owners of the file. And third one is other. Other represents everybody else that is all on the Linux. So these are the 3 user groups that we have for a file or a directory. And RWX, read, write, execute, are the permissions that we have. If we want to give certain permissions, we are going to use it with plus. And if we want to remove the permissions, then we're going to use it with minus. Here they have taken the X sign, which stands for executable permissions. So minus X, it stands for removing executable permissions, and plus X stands for enabling the executable permissions. Okay, so if we do ls here, we have just an out.txt file. Let's go back. Let's go a step back. Okay, let's stay inside temp. Yeah, so yeah. If I do ls minus l, we learned about this option. This is a long list format. If we do that, you can see here that these are the permissions that I was just talking about. And this is specifically for user group other. So it can be RWX, RWX, RWX. But for this out.txt file, we have only read write because we learned that this is not an executable file. This is just a text file. So there is not execute permission over here. And user and group has both the read and write permissions, but everybody else on Linux, they'll not be able to write to this file. They might be able to, they will be able to read this file, but not write anything to this file because I have created this file. But let's say I want to give everybody the access to this file to be able to write to this file. So we can change the permissions using the chmod command. We can use chmod group because we want to add permissions to the group user and we want to give it the right permissions. So chmod group plus w, which means add the right permissions for out.txt file. And if we execute it and then try to again see the permissions. Oh, I'm sorry, I did one mistake. So group already has write permissions. I had to give it to other. And if we see now, so the other group also has write permissions. So anybody on this system now can access, if they know the path, they'll be able to open the file and they can also write in this file. This is not advisable because we don't want everybody on Linux to be able to access our files and change our files. So usually files are in read-only mode. So let's now remove these permissions. So we should, to remove the permissions, we're going to do other minus w out.txt. So this is going to take us back and we have removed these write permissions for everyone else, except for the owners. So that is how the chmod command works, and it is used to change the permissions for these read, write, execute. Sometimes people tend to use the 755. So that's like there are certain codes related to these permissions. You can also use that. And I preferred this one because it's easier to remember, plus, minus, and user group other. So if it's a text file, if you want to remove the execute permissions, you do a minus X. And if you can combine also, U and G can be combined together, and then we can remove the execute permissions from both the user and the group. So that's how this command works. It is used for changing the permissions on the files. Okay, the next one is how we can edit the files on Linux. One way is to use there are some editors within the Linux like VI and gedit, but we want to promote the usage of our portal, the on-demand portal, because it is very easy, and we have created the portal, so we want everyone to definitely use it. Let's try to see how we can edit files with the portal. On the portal itself here, on the red banner here, you can see the menu option and files. You can see the home directory and the scratch directory. So let's go to the scratch directory. And I can see all the folders that I was just seeing through the terminal. I can see it in this mode as well. Now, if I want to create a new directory, I can create a new directory, Linux primer directory. So I can create a new directory over here, and I can also create a new file within the directory using just these buttons, and it's easy to use and it's easy to edit. So we want and encourage everyone to use these files, especially when you are new in Linux. It's a little difficult to use the editors. So this is one way that you can use to edit the files. Now we have another exercise for you. So that's a shell script exercise. Before that, I want to talk about what a shell script is. So we have bash. So bash terminal, the terminal that we are writing on, it's like a command line interpreter. So you can see that this is this bash, the terminal that I'm writing on, it is able to interpret the commands that I'm writing. So it's basically a language interpreter that is letting me talk to the computer. So it also hides the operating system and lets us interact with the OS. And sometimes bash is also a scripting language. So that's how the shell script, that's what the shell script is about. And it's called a shell because it hides the details of the OS and it's giving you a user interface to interact with the OS. So we have used the Vim editor here to create the script. You can use some other editor also. And this is the script that we will write, and then we will try to execute it and change the permissions and execute it. So let's try this exercise. You can use if you're not familiar with Vim, please use the portal editor that I just talked about. So so this is the Vim editor, and I'm trying to use that in Linux here. So this is the script that we want to type out. The first command over here, I hope it's visible to everyone. I'm trying to increase the font. Yeah. So hashtag exclamation bin bash. This invokes the interpreter, the bash language, and it tells us that the rest of the code inside is a shell script. Okay. So Dylan used to teach this course, but now I am teaching it. So I will write, my name is Aditi. Okay. Then we have this my name equal to Dylan or my name equal to Aditi. The my underscore name is a variable. So in the variable, we have passed it a string, and the string name is like Dylan, Aditi, so whatever it is. So that's a variable in Linux. Now, if you're familiar with Python somewhat, to print something, we have the print command in Python. Here in Bash, in Linux, we have the echo command, and using that, it achieves the same purpose. It basically prints whatever is within this string onto the terminal. So instead of printing it onto the terminal, what we are trying to do here is redirect it to a names.txt file. So we learned about the redirection operator. This is going to redirect the output of the echo command to names.txt file. So let's do that. So echo howdy. The dollar here is used to reference the variable that we just created. And we're gonna redirect it to the names.txt file. Okay. And then we will create a directory, make directory. So all the stuff that you do on one by one, type command one by one on the terminal, you can combine it all in a shell script. So we can do mkdir, make directory, and then we can create the directory script output. Okay. And then we can move the file that we have just created. So this is another command in Linux, mv, that's going to move the file names.txt in the script output file. So this is what the command is doing, move the names.txt in the script.file. Then it is changing the directory, going to this output file, and it is using cat to print the output on the terminal or whatever is there in names.txt. So let's do that. Let's go to change directory, script underscore output, and then we will just do cat names.txt. So that's the file. Another thing I missed here is this hashtag HPRC shell script exercise. Let's do that also. The hashtag here, this line is basically a comment. So like we add comments in Python or any other language, we can also add comments in a shell script. So you can write HPRC shell script exercise. Okay. Yes. So in Vim, now I was in the insert mode. Now I'm going to use the :WQ and I'm going to go out and save this file. Let's do ls to see if we have that file. We have myscript.sh. If you see the color of this is white. So this is not an executable file. We thought that executable files are green in color. Let's see the permissions of this file, ls-l. If you see the permissions of my script, it doesn't have the execute permissions as well, right? And we want to give it the execute permissions because we want to execute the shell script. How we do that is with chmod. We do user, give it the execute permissions, myscript.sh, and we run it. Let's again try to see the permissions using the ls-l command. Now the color has changed to green. So now it has become an executable file and we have an X over here. That means we can execute it. So now let's try to execute it. How we execute it is with the command, myscript.sh. And if we see the output, you can see we had redirected the output to names.txt. Then we went to names.txt and cat the output of names.txt, and we got howdy Aditi in it that we had printed. So that completes our shell script exercise. And if I had to do that all on the terminal, I had to use one command at a time. I can create variables as like one variable here as well, but then I'll have to echo it and then use it as one command as opposed to writing the whole script over here. Everything is inside this. I have declared a variable. I have printed the name and then redirected to names.txt file. Then I created a directory. I moved the file to the directory, went to the directory, changed directory, went to the newly created directory, and then we used cat to print the contents of the output file. And this is our HPRC shell script exercise, which we know by the comment over here. The hashtag, just one single hashtag is used to comment in the shell scripts. And the first line over here, it invokes the bash shell interpreter to interpret this as one script, bash script. So now with the WQ exit, I just exited the script over here. So that is the exercise we had, the most important, and I hope that you are able to follow along with the exercise. If there is any problem, just let us know. And final command that we want to talk about is the exit. So if we want to log out of the FASTR portal, you just need to type exit, and the session is going to end and you will be logged out of your terminal. I'm not going to do it right now because if anybody has any questions, I don't want to exit the terminal yet. But that's how you can close the terminal and then relax after your work is done. So thank you very much. If there are any questions, please feel free to ask them right now by unmuting yourself or putting the questions in chat. So these are different directories. We have the home directory and the scratch directory. These are just two different spaces on our cluster. With respect to Linux, I don't mean to teach you about the scratch right now. You just remember that as we log into the system, you are redirected to your home directory. And if you want to learn about like scratch directory, what it means, I request you to please join the second primer that we have, Introduction to FASTR. And that's where you will learn about what scratch stands for and how it fits in with the FASTR supercomputer that we have, the resources that we have. If you need more help, we have these links, the common problems that people face while using the resources, our user guide, and we have a very robust help desk system where we answer to any problems that you are facing. So if you just email your questions to help@hprc.tamu.edu, you will be there'll be a ticket that'll be created, and we'll be able to see that, and we'll be able to assist you with the ticket. So you can send us any problems that you have. So if you want to learn more about our resources, we have the video tutorial series over here. Click at this link that will redirect you to our YouTube page. And we have our very elaborate wiki page, which we try to update on a daily basis. So please refer to these resources. And also stay tuned for our other primers. We have a series of primers coming up every Tuesdays and Friday, and they are going to be online, all the primers this time, I guess. And if somebody can also post a primer schedule, that will be great. We have one today in the afternoon, Introduction to FASTR, the resource that I just talked about. And you can also learn about that resource and understand how to use it, what are the limits of different nodes, and all that information will be included at the primer. Thank you everyone for joining in and for your time. Hope you enjoyed the session.